So I haven't tried to explain this too often, but I figured I'd give it a shot. So what we have here is a door. And this door is basically just a polygon door, handle, door, frame, some hinges. So while you only need one way to control this door, basically you want to be able to turn the knob and open the door, I've actually created several ways to control the door, just to give an example of different ways it can be approached. So we have a panel, so you can open and close the door, and there's a slider to turn the knob. Fairly simple, fairly straightforward, but as an alternative, I also have more direct controls or direct point controls, basically aligned with the geometry and the targeted area of control. And so I can easily rotate the door open, close it, and as you can see, the controls maintain their alignment. And yet, I still have full control from the panel as well. Okay, so this is what I'd call a layered control setup, or a redundant control setup. Yet I have a third layer of control. So I can just use attributes on the world control to open and close the door as well, and turn the knob. Okay, so that's 3 layers of control. Not necessary, but sometimes when you actually have a complicated character, it's good to have sort of a general control and then have some more specific control within it, sort of layered influence. Now, this manual control has something that the others don't. I can actually translate the door away from the main. I can animate the door independently of the frame so that I can actually detach the door if I want to. Okay? So that's just one advantage of having a layered control setup, because I have the ability to do that and yet still have the other controls influence it. So I turn the doorknob, take this control, and pull it away, and the doorknob is still turned. It still functions relative to the panel. And even the door will still try to open and close, but it's trying to open and close relative to a pivot point that is not aligned with where the door is. But that's a disadvantage of the layered control. So everything works under certain conditions. So while making a setup like this looks a little tricky, it's not too difficult. It's actually very simple. It's just a matter of setting up a base or foundation and then creating layers of control on top of it, building up. It's all about hierarchy, hierarchical relationships, and controlling each one of those layers. So I'm going to hide this door, and I'll bring up a door that I can actually show you how to get this working on. So here's my door. Okay, this is the blue door, the unrigged door. And I've already placed a joint relative to where I want the door to pivot. So this joint is currently perfectly aligned with the pivot point of this hinge. And since I only need one pivot point to control the entire side, and to control the door, control the hinges, one joint. So to get started, we're going to select all the geometry and just bind it to our common pivot point. Now, while I'm just showing a setup for this door, I'm specifically trying to show you how to layer control. So I'm going to go to Skin, Smooth Bind. I'm just going to bind the selected pieces of geometry to that joint. And notice I'm actually leaving the door handle out, because I'm going to control that in a slightly different way. Okay, so I'm going to do selected joints, and I don't need maintain max influences or anything like that. Just selected joints, and I'll do a bind. So now when I rotate the joint, it will actually rotate the door, and notice it brings the hinges with it. Hinges actually pivot relative to that pivot point, so it's perfect. Now I need to make sure that the handle follows. Okay, so taking the joint and connecting the geometry to the joint, that was sort of the first layer of control, the binding. Now I need this handle, the knob, to actually rotate. and to stay aligned with the door. Okay, while leaving it open to future control. So one of the easiest ways to do that is to take the knob and to group it. Okay, so now that I have my group for the knob, I need to make sure I go in and name it. So knob group. Okay. Always name everything you create so you can keep track of it. And while I still have that group selected, and I'm just going to go to the outliner and show you, I have the group selected, not the geometry. See, the geometry is here. And I've got a constraint on there. Okay, so there I've got the group. And I need to actually center pivot this, so I'm going to toggle the pivot point on. I'm just pressing and holding the letter D. D as in dog. On the keyboard, just so I can just nudge the pivot over. I'm going to go to my front view, my front orthographic view, and sort of focus in on this area so I can properly align it. So with the pivot point toggled on, I'm going to grab the x-axis. I'm going to try and snap it relative to the center of the circular base of the knob, and then center it relative to this central edge here. So now the pivot point is perfectly aligned with my knob. And I need it centered for the knob so that it can actually rotate the knob perfectly. Okay, so I have a group around there. Okay, and now the simplest way to get this group to stay aligned with the rotation of the door is to simply take that group and then just parent it. Not constrain, just parent. So select the group, shift select the hinge joint, and then press P. And it just basically adds it. It adds that group to the joint as a child, so it's part of its hierarchy. And so now when I rotate the door, the knob goes with it. And since the knob is inside of a group and not constrained, I can still rotate the knob without having to compete with any other incoming connections. Okay? So that's basically the first layer of control for the door, because now we have the door controlled and the knob controlled. So now if we actually wanted to set up a control panel, or let's actually start with the direct point controls. Direct point controls meaning controls aligned with the elements they're controlling. So I'm going to create just a NURBS primitive circle, and I'm going to snap align it with my joint, snapping the point because essentially a joint is just a pivot point. Okay, so once that's in position, I can do a modify and freeze transformation just to completely zero out that control. And of course, rename my control. I'll call that my hinge control. Okay, and so now the simplest way to control that joint is I can select the curve, shift select the joint, and then go to constrain, and I can do a parent constraint, go to the option box. And I can do a parent constraint maintaining offset. Add that in there. And so now this control now controls the door. So I can pick the door up, I can move it around. And so that is officially our first control layer. And so I can rotate that to open the door, and everything works as necessary. So next we need to control the knob. So in that case, we're going to need yet another control circle. So I'm just going to duplicate my hinge control curve, and since it was constraining, there's no connections. It's just a copy of the control. And so this I'm going to rotate about 90 degrees on the x-axis, and we'll try to once again snap align this with our, and once again modify freeze transform it so it zeroes out all the translates, rotates, and scale. And just to make it a little easier to read, I'm going to select 4 of the points, scale them in just to make a slightly more recognizable, and we'll call this my knob control. So now, to get this to actually control our knob, I can do a couple of different things. I could have it control the geometry directly, but if I want to keep the geometry independent of any sort of input, I can just take control of the group's rotation. But before I do that, I need to make sure that my control is properly anchored. And so one of the easiest ways to do that is going to be to basically once again use the hierarchy to my advantage. So I can take that curve, shift select the hinge control and just parent it directly to that. And so now it is anchored to stay aligned relative to the door's movement. And now I just need to control the doorknob. So I can select my control for the knob, and I can command or control select the knob group, and then I can go to constrain, and I can do a parent constraint, because I'm going to want that control to be able to control translation and rotation. So I go to parent constraint, option box, make sure maintain offsets on, and then just add that in there. So once I have that constrained, not only does it control the rotation of my knob, it will also control the translation if I choose to displace the knob and reposition it on the door for some reason. So again, this is hierarchy and related connections, control, adding a layer of control. And so what if I wanted to add yet another layer of control? So if I wanted to add a panel to control the same things once again. I'll create a panel really quick. So I put together a really quick panel and a couple of sliders, one for the door, one for the doorknob. So if we want to actually add these controls so that they actually control the same behaviors without disrupting the control of the existing controls, we basically have to create yet another layer. So let's start with the door. So with the door, we have this control curve that controls the rotation and the translation of the door. Okay. Now with the slider panel, I'm just going to focus on just controlling the rotation, not the translation necessarily. Although I could potentially do both. So in this case, we have the control. Now we want that control to maintain its alignment, yet still be able to control the rotation of the door in spite of the panel also controlling it. So simple way to do that, another group. So select the control group it so that we have a group around the control now. And I'm going to name that, we'll call that my hinge control group. So a group around the control. And once again, we need that pivot point to align with the center of our joint. And so you can do a snap, activate pivot point of that group, and then point snap it to the joint. And it should align with it perfectly. Okay, so once you have that group around your hinge control, then you need to set up a way for the door slider to control the rotation. Now, since the slider only has a limit of -1 to 1, that's not going to be enough to actually open the door any further than essentially like 1 degree. So what we need to do is we need to take that control, and we need to take the hinge group, which is now controlling its rotation. So if I rotate that on the y-axis, it will open the door. If I want my slider to control that rotation, I need to load both of these into the node editor. Or I could even use set-driven keys for this, but I like using nodes just because they're a little more concrete, stable, and less likely to be confused with keyframes. Okay, so now what you want to do is you want to create a node to control or to make the bridge between the translation and the rotation of the door. Of course, I don't want the door loaded in here. I actually want the group. So make sure that you're loading in the hinge control group, the one that you just created. Okay, so you want that, and you want to make sure that you're loading in, of course, your door control, and you want to make sure you're using the transform nodes, not the shape node. So the transform node, usually the one with the arrow and the little slanted white box in it, those are your transform nodes. And so to create the set range node, you want to press tab, of course, type set and range, and then press enter, and it'll create it and rename it. I like to rename things according to what they're going to control, and so this one's my set RNG underscore door. And so I need to connect its out value X into my hinge control group's rotation under rotate Y. So it's going to control its rotate Y, which is relative to the axes that it needs to essentially pivot around in order to open the door. And now for the slider control itself, its translate X value is actually going to be driving the action. So I'm going to take its translate X value, and we're going to feed that into the value X, so that's feeding into our set door. So now we just need to take the set range door node and make some adjustments. So the default input is basically going to be 0 to a positive 1, because I'm probably not going to use the negative. So I'm just going to say max value is going to be 1, minimum value is going to be 0. So that way if it goes negative, it shouldn't do anything at all. And the new output value, minimum value is going to be 0, and the maximum needs to be relative to essentially the value that's necessary to actually rotate the door open. Now in this case, that value is going to be a negative value because it's rotating towards the camera, which is essentially negative. It's rotating towards the negative on the y-axis. So I need to make sure that when I set that value in the node, that the minimum is actually going to be the largest value, or the largest negative value in this case. Now, since the door needs to sort of swing negatively, technically the negative value is going to be the max value. So I'm going to make the max value negative 150, minimum value is going to be 0, 0 being the default. Okay, so when I close this now, and I go to my slider and I grab it and pull it towards 1, it opens the door and goes to 0 and closes it. And notice once it goes below 0, it doesn't do anything. So if I go to negative 1, it just stays closed. I have to go past 0 to 1 for it to actually open my door. Okay, so next, we need to set up the knob. And essentially it's going to be the same process again. Node, editor, load in my slider control. I need to rename that slider. Call that knob. Okay, and I can show you a slight variation. So instead of doing a set range node, I'll do a multiply divide node instead. So I'm going to press tab, multi, find it in the list, press enter to complete it, and I'll call this one my mdiv underscore knob. I'll call it my knob node. So then with the knob I need to do something a little different again, because since with the knob I already have the control on there and it doesn't have a group around it, it's just parented directly to the next control. What I can do is I can select that control and once again group it, and Maya will automatically generate a group for that knob within the existing hierarchy. So that group is actually now is actually parented to the curve that the door is being controlled by. And that's because the curve, again, was already parented to that curve. So when I created a group around that curve, it sort of slipped the group in around the curve, but within the existing hierarchy. So if I expand the hinge control group and find the hinge control curve, you'll see that I have a brand new group sitting directly beneath it now, and that is the group that contains our knob. And so I can rename that one my knob control group. Okay, so once again we want our pivot point to sort of center around the knob. Let's modify center pivot. Now essentially everything's going to come down to pivot points being aligned where they need to be and then controlling the object with that pivot point. Now a lot of this can be done with joints, but joints are basically just another way of, they're just a visible representation of a pivot point. While a group is essentially the same, can do the same thing without the visual clutter. Okay, so now that group is perfectly aligned, so if I actually rotate that group, you can see it perfectly rotates the knob. No problem. And so now I just need to make certain connections. So with my node editor already open, and my group is already loaded in, because I had it open while I was creating it, I need to make certain connections. So I need the knob control from the slider is translate X value, feeds into the multiply divide node, and I'll feed it into the input 1x of the multiply divide node. Okay, and then I'll feed the output from there, the output x, to the group node, or to the group that's surrounding the control of the knob. And in this case, it's going to be the rotate Z axis, which is the axis that faces the camera, which is going to control the rotation of our knob. So I'm going to feed the output directly to that. And so by default, it's going to be equal to 0. So I need to go to the multiply divide node and make a little change now. So by default, the multiply divide node is set to divide, or multiply, sorry. So what I need to do is on the input 2, I need to tell it what to multiply the input by. And so I'm going to want my knob to basically rotate at least 90 degrees in either direction. So I could just type in 90. Okay? And so now if I actually come in and go to my control, my slider control for the knob, and I will translate that, notice it's turning the knob. And so basically what we have here now is we have a setup that has provided us with layered control, because now I have 2 ways to control the door, which can add to each other, by the way. And of course I also have the same thing for the knob. So I can rotate the knob manually, no problem. And I can also use the slider to counter animate it and animate it further. So now with this setup, we have basically the same thing that I start with the other setup. I can move the door using the manual control, I can rotate it, and I can use the slider panel to open and close the door and turn the knob. Now, one thing, if I actually reversed the order of the connections for the hinge, I could actually make it so that it would still pivot correctly even when the door was detached. And so that's pretty simple. I mean, it's just a matter of changing a few connections here and there. For example, if I take the hinge, delete the constraint that's on that one, and so now this curve control doesn't control the door in that way anymore, at least not yet. Now if I actually take this control and I'll group it, align the pivot point with the joints, and we'll call this my joint hinge group. Okay, and now I'll take my control curve and I'll have it parent constrain the joint hinge group instead. And so now I can take the group that I originally created around the control and I can just get rid of that one. I won't need it at all. So I'm just going to edit and I'll just ungroup it, and it'll immediately destroy any incoming connections. And so I now just have the control free floating, and I have the joint itself is inside of a group that's now being controlled by that very curve. Okay, so now if I want to have the panel control it, I need to connect the panel so that it actually controls the joint directly instead. So it puts the panel's control of the joint on the bottommost level within the control of the curve. So if I move the entire structure, the slider will still work and the control curve will still work. So all I have to do is make that final connection. So I need the joint itself. I need to load up the panel, node editor, and I'll actually need the set range node. So what I can do is I can actually select the curve that's already connecting to it, and I can load that in here, and I can select it, and then I can use this button here to show all the incoming connections to it, so I can get the range node, but I'll have to reload the joint. So we'll just add that back in here. And now I need to feed its output, so the out value X, into the, once again, the rotate Y of that joint directly. And so now when I test it, go to the slider, translate it, opens the door. Okay. Now the one problem with that is that this control is no longer on the right layer. Okay, so I need to take that and have it respond directly to the joint. And so in this case we have this, we have the group that's around it, and the group that's around it is currently being controlled by the knob control. So I need to take that group and I need to parent it to another level. So now it should be parented directly to the joint. So now the knob should work, and the knob should work. Okay, so it works in both cases. And now we have also that working, and we also have our slider, which should work as well. Okay, so all of our controls now work no matter where the door is. So this is just one example of how one might use hierarchy and some very basic connections to create what I like to call a layered or an additive control setup. This kind of setup can be applied to pretty much anything. Not specifically the creation of a hinge and a knob, but I'm just talking about the layering of input relative to relationships between parent and child objects. Because even if I just wanted to control the door using, let's say, 50 different inputs, I could do so just by creating in infinite layers of hierarchies. And so you could actually have multiple kinds of input, whether it's scale, rotation, or translation, controlling a common type of output, just depending on how you actually set up the hierarchy and fed the information through to the attributes that need to receive and execute the transformation.